This is mathheals.com, where you can find more links to YouTube math videos and computer science, if you wish. Let's take a look at integration by substitution and general power rule. Let me first write down the formula for the general power rule. It says if we have the integral of, instead of x to a power, we have u to a power. And you can almost represent, well, it can represent everything if it fits in. We have du dx here. This is the derivative of u. And then dx here. Well, that's going to give us the integral of u to the n du, which gives us u to the n plus 1 divided by n plus 1 plus c. Okay. Now, I almost thought about working at one problem before I wrote this down. But guidelines for u. We're going to add on to this. If you got parentheses to a power, then we let u equal to what's inside the parentheses. If you have a radical of some form, then u will be what's inside the radical. Like I say, we'll add on to those. There's more than two, but we'll start with those. Let's look at our first problem here. We got the integral of x minus 7 to the 3/2 power dx. Well, it's more than just x to a power, but if we let what's inside the parentheses be u, because that's what our guideline was, u is equal to x minus 7, then I won't show all the steps here, but the derivative of u with respect to x, I will show all the steps in this first one, but I won't from here on. So derivative of u with respect to x is equal to 1. Now, there we go. If we treat these like variables, we can multiply both sides by dx, like this. And then these dx's would cancel. And we get du is equal to, the 1 disappears, and we just got dx. Now basically, after you've taken the derivative, then you just put dx on the other side. And we'll use a shortened version of this in the next problem. Well, this now becomes, we replace the x minus 7 with u. That side right there is this right here. So that becomes u to the 3/2, and the dx, it's right here, is right here. It gets replaced by du. Okay, so now we got u to a power, so we're going to add 1 to our power, divide by our new power. So we have 3/2 plus 1, and then divided by 3/2 plus 1, and then plus c. Well, 3/2 plus 1 gives us 5/2, and then 5/2 down here, plus c. Remember, if you have a single fraction down in the denominator, you flip it and multiply it times your top part. So we're going to have 2/5 u to the 5/2 plus c. Up above, we said u was x minus 7, so we're going to plug in the x minus 7 for our u now. So this will be 2/5 x minus 7 to the 5/2 plus c. And that's our answer. Take a look at another problem. integral of x squared minus 3 to the 5th power 2x dx. Okay, now remember our guidelines. We said let u equal to if you got parentheses to a power or if you got a radical. Well, we got parentheses to a power here, so we're going to let u equal to what's inside parentheses here. So u is equal to x squared minus 3. Now the derivative of u, derivative of x squared minus 3 is 2x, but we have to add on a dx for the very reason that we said over here. I won't show all those steps, but it's really du over dx. You multiply both sides by dx. You can think of it along those lines. So now we're ready to do our u substitution. So this gets replaced by u. So we got u to the 5th. The let me write that down. This right here gets replaced by this. And then the 2x dx gets replaced by du. Now it has to match exactly. If I didn't have a 2 here, I'd have to get a 2 there somehow. Okay, so now we're going to add 1 to our power, divide by our new power, plus c. So that gives us 1/6, u to the 6, and u was x squared minus 3. So we got x squared minus 3 to the 6th power, plus c. And that's our answer. Okay, number 3. We got the integral of x to the 4th minus 7x plus 2 to the 8th power times 4x to the 3rd minus 7 dx. Okay, we're going to remember our guidelines. If we have parentheses to a power, we let u equal to what's inside the parentheses. So u is equal to x to the 4th minus 7x plus 2. Now the derivative of that. The derivative of that would be 4x to the 3rd minus 7. Remember, you take your power, put it out in front, lower it by 1. And then we have to add on our dx. So this right here, this x to the 4th minus 7x plus 2, gets replaced by u. So this will be u to the 8th. This 4x to the 3rd minus 7 dx and this 4x to the 3rd minus 7 dx match. So we're going to replace this with du. And now we got a variable to a power, so we'll add 1 to our power, divide by our new power. So we got u to the 9th over 9 plus c. And I'll take that 9, put it out in front as 1/9. And we got u to the 9th. And u we said was this. So we got x to the 4th minus 7x plus 2 to the 9th power plus c. Okay. I probably have room for it, but let me go ahead and start a new page anyway. Okay, this is integration by substitution and general power rule. Integration by substitution and general power rule, page 01.pdf. There we go. Okay, number 4. Got the integral of the 5th root of 2 plus 3x squared 6x dx. Remember what we said about our guidelines. If you have a radical, let u equal to what's underneath the radical. So we got u is equal to 2 plus 3x squared. The derivative of that, du, the 2 drops away. The derivative of 3x squared is 6x. Take your power, put it out in front, lower it by 1. And then we have to add on our dx. Well, this matches that. So this becomes the integral of the 5th root of u 6x dx, that gets replaced by du. Now we can rewrite the fifth root of u as u to the 1/5 power, du. Now we're going to add 1 to our power. So we got u to the 1/5 plus 1, divide by our new power, plus c. Now this gives us 6/5. So 6/5 here. That's a mixed number, by the way. 1 times 5 is 5, plus 1 is 6, and then the denominator stays the same. Remember, if we have a single fraction downstairs, we flip it and multiply it times the top part, so it becomes 5/6 u to the 6/5 plus c. And u, we said, was 2 plus 3x squared. So we got 5/6, 2 plus 3x squared to the 6/5 power plus c. I'm guessing they probably leave their answer in that form instead of putting it in radical. Let's look at this one. The integral of 2x minus 1 over x squared minus x to the 3rd power dx. Our guidelines: if you have parentheses to a power, which we do down here, then let u equal to what's inside the parentheses. So u is equal to x squared minus x. The derivative of that, du, that'll be 2x minus 1. And then we have to throw on a dx. Okay, so that matches this. So this becomes the integral of 1 over u to the 3rd. The 2x minus 1 dx, 2x minus 1 dx. These in blue get replaced by du. Now remember, we can, if you got something down in the denominator, you can take it on top. Take anything opposite of where it's at in a fraction, the sign of the exponent changes, so this becomes u to the negative 3 du. Okay, add 1 to our power, so we got negative 3 plus 1. Divide by your new power, negative 3 plus 1, plus c. Okay, so that gives us u to the negative 2 over negative 2 plus c. I'm going to bring the u to the negative 2 down to the denominator. It becomes u to the positive 2. So we got 1 over negative 2 u to the positive 2 plus c. And we said u is x squared minus x. So this will be 1 over negative 2 times x squared minus x squared plus c. That's our answer. Grab a drink here. I didn't put a power here. Let me put a power there. Let's only put a 3rd power. There. Otherwise, it's really not a substitution problem. Let me save this. There we go. Number 6. We got the integral of x times 7x squared minus 2 to the 3rd power dx. Okay. If you got parentheses to a power, you let u equal to what's inside the parentheses. So u is equal to 7x squared minus 2. Du, the derivative of this, would be 14x, then minus 2 drops away, and then we'll throw on our dx. Okay, now it has to match exactly. This matches that, so that's good. We can replace that with u. du, we have 14x dx. So we have the dx, that's there, that's good. We have the x, that's good. What we don't have is we don't have the 14 in there. Well, let's put the 14 in there. Try it again. Okay, that looks better. We needed 14x and dx. Now we have 14, we have x, and we have dx. They don't have to be right next to each other. So we have all three of them. Now we can't just throw this in here without offsetting it somehow. We put a 14 here, we put a 1 over 14 out in front. You put the reciprocal of it out in front. Okay. So this red right here, that's our u. So we got u to the third. And the 14x dx gets replaced by du. Okay, add 1 to our power, divide by our new power. And then plus c. So that's going to give us 56, 1 over 56. U, which u was 7x squared minus 2. So we got 7x squared minus 2 to the fourth power plus c. And that's our answer. Let's look at this one. We got the integral of x to the third over x to the fourth minus 3 raised to the fifth power dx. Again, our guidelines are if we have a radical, u is what's underneath the radical. If you have parentheses to a power, you let u equal to what's inside the parentheses. So we got x to the fourth minus 3 du. The derivative of that would give us 4x to the third. The minus 3 drops away. And then remember we have to throw the dx on there. Okay, so this right here matches that. That's good. X to the third matches that. That's good. Dx matches that. That's good. We need a 4 in there, though. So let's put a 4 in there. So we're going to have 4x to the third. Down here, x to the fourth minus 3 to the fifth dx. Again, that matches still. Now we have a 4, x to the third, dx. Matches exactly. Now we can't just throw it in there, though. We have to offset it somehow. We put a 4 inside, so we'll put the reciprocal out in front. We'll put the 1/4 out in front. And now we're ready for our u substitution. This becomes u to the fifth. 4x to the third dx, 4x to the third dx becomes du. Now, we need it as u to a power, so I'm going to take that u to the fifth and move it up to the numerator, move it up on top. When you move anything opposite where it's at in a fraction, the sign of the exponent changes. So this becomes u to the negative 5 du. Okay, add 1 to our power, divide by our new power, and plus c. So we got 1/4 times u to the negative 4 over negative 4 plus c, which gives us u to the negative 4. 4 times negative 4 is negative 16 plus c. Don't want any negative exponents, so I'm going to take this u to the negative 4 and move it down to the denominator, move it downstairs. And we get 1 over negative 16 u to the fourth plus c. But up above, we said u was x to the fourth minus 3. So we're going to replace u with x to the fourth minus 3. To the fourth power plus c. And that's our answer. Let's look at this one. The integral of 3x squared plus 6x to the 10th power, and then x plus 1 dx. Okay. Try and figure out what our u substitution should be. We let u, if we got parentheses to a power, we let u equal to be what's inside the parentheses. So I got u is equal to 3x squared plus 6x. Du is equal to 6x plus 6, and then we have to throw on our dx. Well, that doesn't quite match what we have here. See how we have an x plus 1? But notice that these have a 6 in common. So I could factor a 6 out, and that gives us x plus 1. So now you see that they do have something in common. Now we have the x plus 1 in here, we have the dx in there, but we don't have a 6. So let's put a 6 in there. Now that 6 doesn't have to be next to the other parts, because all of this is multiplication. Well, this part here is multiplication / notation, so it's a little bit of both there. But so this right here is our u. Here's our 6, matches that. X plus 1 matches that. Dx matches that. So this red right here, that becomes u to the 10th. And then 6 x plus 1 dx. 6 x plus 1 dx becomes du. Okay. Now we'll do our formula. Add 1 to our power, divide by a new power. So it becomes 11 u to the 11th over 11 plus c. And up here we said u is equal to 3x squared plus 6x. So we got 1/11 3x squared plus 6x to the 11th power plus c. And that's our answer. Let me save that. Got like Jason part 20 on TV right now. It's like has some dignity. I'm not sure what point it lost its dignity. Maybe Jason part 7. Just looks stupid. Well, not that it ever wasn't stupid, but okay. Let's look at this problem. I'll ignore Jason. Again, it's pretty easy, these first ones, to figure out what your u is going to be. It's either a parentheses to a power or it's a radical. So we'll let u equal to x to the 3rd minus 4. The derivative of that would be 3x squared dx. We got the x squared, we got the dx, we don't have the 3, but we have a 5. Well, if you got an extra number like that, just take it and put it out in front. We don't even want to worry about it. Now the number we need inside is a 3. So I'll put a 3 in there, and I'll offset it with a 1/3 out in front. I'm trying to remember if I offset the other one. The last problem I did. If I didn't, you need to offset it when you put a number inside. That's going to bother me now. Too busy watching Jason. I should have been focusing on the problem. Good thing Halloween wasn't on. Okay, 6 there. Put a 6, and I knew it. I didn't put a 1/6 out in front. So we need a 1/6 out in front here. I wish I could actually write on this. It doesn't look like it. Is there any way to write it here? No. That stinks. Oh well. So that should be a 1/6 out in front, and then this would be 66. I knew it when I sitting there watching that silly show. Okay. Anytime you put a number inside, you have to offset it with the reciprocal out in front. Okay, so now we have our 3 inside. The x squared is still there. and then the square root of x to the third minus 4 dx. So this here matches that. So we'll replace that with u. The 3, x squared, dx, dx. So all three of those match. Those blue ones are going to be replaced by du. So this is going to be 5/3. And then this becomes the square root of u du. Which square root of u is u to the 1/2 du. Okay, then we're going to add 1 to our power, divide by our new power, and plus c. So it gives us 5/3. 1/2 plus 1 is 3/2, and then 3/2 down here. Now remember, if you have a single fraction down in the denominator, you're going to flip it, multiply times your top part. So this is going to become 5/3 times 2/3 u to the 3/2 plus c, which gives us 10/9. And u up above we said was x to the third minus 4. So plug that back in now. So x to the third minus 4 to the 3/2 plus c. Let me go back and work this one I screwed up. 8 done right. Not watching Jason. I remember when the original Friday 13th came out. Good show then, back then, I think. Not as good as Halloween. You can't beat a Halloween movie. Okay, 3x squared plus 6x to the 10th. X plus 1 dx. Okay. Again, you have parentheses to a power, you let that be your u. So we got u is equal to 3x squared plus 6x. And then take derivative of it. So that'd give us 6x plus 6 dx. And again, remember that doesn't match that, so we have to factor out a 6. And that gives us x plus 1 dx. Okay, so we need a 6 inside. So put a 6 inside, and we offset it with a 1/6 out in front. So then I got 3x squared plus 6x to the 10th power, x plus 1 dx. Okay, this right here matches that. 6, x plus 1, dx, dx. All three of those match. So this becomes u to the 10th du. All these get replaced by du. Okay, add 1 to our power. Divide by our new power. And then plus c. Which gives us 1 over 66. And u, we said, was 3x squared plus 6x. So this is 3x squared plus 6x to the 11th power plus c. Do I have room? Yeah. I should have room for another one. Okay, I think I just did that one. Number 9. Yeah. Come down to number 10. We got 6x minus 21 over x squared minus 7x plus 1 to the 4th power dx. Okay, we got parentheses to a power, so we know what to set u equal to. U is what's inside the parentheses. So we got x squared minus 7x plus 1 du. The derivative of that would be 2x minus 7 dx. Well, if I look at this, that doesn't match. But I see the top part are divisible by 3, so I can factor a 3 out, and that gives us 2x minus 7. And that's looking good now. Now notice we have an extra 3 inside there. So I'm going to take that 3 and put it on the outside. And we've got 2x minus 7 over x squared minus 7x plus 1 to the 4th power dx. This is our u, so we're going to replace this with u. The 2x minus 7, here's 2x minus 7. The dx is right there. Too weird. Jason's just turned into like metal or something like that. Just crazy. Okay. So this gets replaced by u. So we got 1 over u to the 4th du. 2x minus 7 dx gets replaced by du, the blue.
Avast virus database has been updated.
Okay. So now this becomes, we take the u to the 4th up on top, becomes u to the negative 4. Because remember, we need is u to a power. Well, add 1 to our power. So we got negative 4 plus 1. Divide by our new power. And then plus c. Negative 4 plus 1 is negative 3. And negative 3 down here. Plus c. I'll put that 3 up on top. So we got 3u to the negative 3 over negative 3 plus c. I'm going to take the u to the negative 3 downstairs. So we got 3 over negative 3u to the positive 3 plus c. Now those 3 is going to cancel, and I can put this negative up on top, so I don't have to worry about it. And u, we said, was x squared minus 7x plus 1. So this becomes x squared minus 7x plus 1 to the 3rd power plus c. And assuming no basic math error, that's our answer. I'm notorious for adding and subtracting and multiplying and dividing wrong, though. There we go. Let's look at the next problem. Okay, we got x. Square root of x squared minus 8 dx. We have a radical, so that's going to be our u. So u is equal to x squared minus 8. The derivative of that, du, will be 2x dx. Well, we have the x, but we don't have a 2. That's easy. We'll put a 2 in there. But we have to offset it with a 1/2 out in front. Okay, so the x squared minus 8 there, we'll replace that. The 2x dx dx, those all get replaced by du. So this becomes 1/2 the integral of the square root of u du, which square root of u is u to the 1/2 du. Now we'll add 1 to our power. So we got 1/2 plus 1. Divide by our new power. 1/2 plus 1 plus c, which gives us u to the 3/2 over 3/2 plus c. Remember, if you have a single fraction downstairs, you flip it and multiply times your top. So I got 1/2 times 2/3 u to the 3/2 plus c. Well, these 2 is going to cancel, and I got 1/3 u, which was x squared minus 8, to the 3/2 power plus c. And that's our answer. Let's take a look at our 12th problem here. The book describes this. It talks about, well, it seems kind of common sense, part of it, but it talks about that for talking about a family earning $25,000, may be able to save $500 and consume only $24,500 of the income. But if you keep going down, like poverty level, 22,000 or something like that, then you'll find that families will use 100% of their income just to pay the bills. So that kind of makes sense. If you go up to somebody that makes 75,000, well, they'll have some extra money left over, which they'll save. They won't use it for all their monthly bills, typically. Though that's not always true. Some people, as they keep getting more and more money, they keep buying more and have more bills. Their rent, their mortgage is more expensive. The car payment is more expensive. Now that's called the marginal propensity to consume, and that's dx over dq. And it says use the marginal propensity to consume, dx over dq, to write q as a function of x, where x is the income and q is the income consumed. Assume that families who have annual incomes of $25,000 or less consume 100% of their income. Use the result of Part A and a spreadsheet to complete the table, showing the income consumed and the income saved, x minus q for various incomes. Okay, we'll come back to that. Let's do the first part here. Number 12. We have dq over dx equals 0.94 x minus 24,999 0.06 x is greater than or equal to 25,000. Now they've come up with this formula in some manner. Don't really worry about right now how they came up with it. They just they've come up with this formula. Well, we want to find q. So to go backwards to find what q is, we're going to take the integral of the derivative. So q is going to be the integral of 0.94 and then x minus 24,999 to the 0.06 dx. Well, to begin with, the 0.94 that's up on top, I'm pretty sure I don't need it, so I'm going to go ahead and throw that clear out in front. I don't want to worry about that. Then this is going to become 1 over x minus 24,999 to the 0.06 power dx. Well, we got parentheses to a power, don't we? So we'll let u equal to what's inside the parentheses, x minus 24,999. du, the derivative of that, the derivative of x is 1. And this derivative of the number drops away. So we've got 1 times dx, or just du is equal to dx. Okay, so our problem becomes 0.94, the integral of 1 over u to the 0.06 power dx. Again, we don't want that down denominator, so we're going to take it, move it up on top, put it in the numerator. It becomes u to the negative 0.06 dx. Let's try that again. Du. I wasn't even watching the show this time. Okay, there we go. Well, now we're going to add 1 to our power, divide by our new power. So this will be interesting. Negative 0.06 plus 1 over negative 0.06 plus 1. which is Q is equal to 0.94 times U was this. So we're going to plug that back in. X minus 24,999. I think that's 0.94. I'm not very good with decimals. Yeah, it is. Divided by 0.94. Oh, that works out really nice. Notice how the 0.94's cancel. Still need our plus C here. Okay, so Q, I guess that's good enough, is equal to X minus 24,999 to the 0.94 power plus C. Well, we need to find out what the C is. The problem reads, assume that families who have annual incomes of 25,000, the income is X. So they're telling us X is 25,000. So I'll plug that in. 25,000 minus 24,999, the 0.94 power plus C. Okay, assume that families who have annual incomes of 25,000, this is X, or less, consume 100% of their income. Now Q, there it is. Q is the income consumed. Well, if they made it 25,000 and they consumed all of it, 100% of it, then that means Q is 25,000. Well, 25,000 minus 24,999 is 1. Now 1 to any power is 1. So we got 1 plus C, take the 1 over, and we got 25,000 minus 1 equals C, which is 24,999 for C. So this formula right here, we now know what C is. So Q is going to equal to X minus 24,999 to the 0.94 power plus 24,999. That's the first part. They want us to find that. Then they want us to do the second part in a spreadsheet. So let's come over here. We got X, 25,000, 50,000, 100,000, and 150,000. And we got Q and X minus Q. Okay, Q, I'm going to do equals. Q is equal to this formula. So we got a beginning parentheses. Now it says X. Well, X we put into B1. So I'll type B1 minus 24,999, close parentheses. This is part right here, close parentheses, then caret 0.94. So caret 0.94, then plus 24,909. 24,999. Enter. And then if I fill that across, it'll look like that. Now remember, assuming this is a valid model, Q is the amount they consume somewhere. There is Q is the income consumed. Well, if they only make 25,000, they use the entire amount just to try to make ends meet. If they get 50,000, then they use about this much to make ends meet. 100,000 this much, 150,000 this much. Okay, X minus C. Well, that's going to be equal to B1 minus B2. Or X minus Q, sorry. And there's 0 there. And this tells you, the difference between them. So how much they got, how much they consumed, and what's left over. And that should be the last problem. So let me save that page. I'll go back to watching Jason. Actually, he's just about over. Jeepers Creepers is getting ready to come on. I love Friday night Fright Fest or whatever they call it on AMC. I grew up watching Frankenstein, The Mummy, and all that. And that's where my heart is these horror type movies. Not quite as good as they were when I was growing up, though. They've lost some of their. They go more for blood now, and that's not so good. But anyway, I'm sure you didn't want to hear that junk. So let me finish this recording.